Hi everyone, in this video we will generate our own self-signed certificate using OpenSSL utility. If you don't have it installed, please install it before going ahead. Our plan for today is to create a self-signed certificate that will be our certificate authority, then to generate a certificate signing request, or CSR for short, and finally to sign this CSR using the CA that we've created in the step 1. In the result of this last operation, we will get a signed certificate that we will put on our Envoy server to terminate TLS encryption between the load balancer and ECS task. I hope you've grasped the idea now, so let me show you a more detailed plan. First, we will create a config file that will be used by the CA and CSR. Then we will create our first private key to sign the CA. Then we will create our second key and we'll use it to sign our CSR. And lastly, as I mentioned in the previous slide, we will sign the CSR using the CA certificate. And here's a graphic representation of all entities that we will need to create and how they correlate with each other. If you are new to OpenSSL and TLS certificate, I would recommend to pause the video here and spend some time analyzing the graph and trying to understand all the relations here. As agreed, let's start with creating our configuration file. I'm using Mac, so if you're on Windows, please remember that your commands will be slightly different, but the idea is obviously the same. So let's create the file. Let's name it CA store, and it must have .cfg file extension. Now use an editor of your choice and let's edit the file. I'm using Vim. Okay, we are inside the CA store file, so let's paste this configuration. We will not go into details now, but spend some time to read and understand the file and also take a note of the comments that are added to some of the name-value pairs. Okay, we will come back to this file later, so for now let's save it. Let's verify the file looks exactly as we want. That looks great, and now we are ready to generate our first RSA private key. So to do that, please enter this command. But before pressing enter, let's break it down what this command actually does. So by sending this command, we are saying OpenSSL, please generate us a private key using an RSA algorithm that will create a key that will be named as castor.key and use this key generation option that will make our key 2048 bits long. Sounds simple, right? So let's press enter. Okay, I feel curious now what the key looks like, so let's have a quick look. Beautiful. Okay, so we are ready to create our certificate authority. Before doing this, clear your terminal and output the config file we've created earlier. I think you will need that to understand this command, the following command better. Alright, so the command to create a CA certificate will be this guy. Let's break it down. So we say OpenSSL, use your rec command that normally deals with certificate requests and certificates, and then generate us a X509 self-signed certificate that should be new, of course. And the next option is nodes. You might thinking, nodes? What nodes are we passing here? No, this is not nodes. It is no DES, no data encryption standard. Basically, we are saying no need to encrypt it, leave it as is. You would need to encrypt it in production, but I'm trying to keep this tutorial as simple as possible, so we will say no DES. Then we say use a private key castor.key to sign it, and keep the certificate valid for 10 years. Then we say please use this configuration file castor.cfg, and in this config file use the v3_ca extension that you can see here to apply the CA extensions to our self-signed certificate. And finally, please save this certificate in the castor.pm file. Alright, so as you can see, we are using this configuration file in the command. So let's see what fields are actually used. Because remember, this config file is quite generic and is being used not just by the CA but also by our CSR. So the first parameter that is used is distinguished name. It tells OpenSSL where to get the subject field in rec distinguished name, which is here. And here we pass our country, organization unit, the CN as well, and our email. Feel free to adjust these name value fields as you wish. You'll probably need to change your country, organization, etc. Then prompt equals no tells us to use values from the config file instead of prompting them interactively. And then next, as you remember, we are using this v3_ca extension, and what it does here, what it says is to, first of all, to add an identifier based on the public key, and then it also helps us identify the certificate issuer, and it's especially useful when you are chaining the certificates. And most important one is here. It says that this certificate will be a CA certificate, which means it can issue other certs. And the v3rec is not used here, it will be used by the CSR. Okay, so let's press enter. Let's verify that the cert is here. Yep, we can see this guy. All good. So let's create our second private key. We're going to use exactly the same command as the last time, so you should already know the routine. Let's find it. Here we go. The only thing we need to change is our name, obviously. Let's call it my-aws-private.key. Let's press enter. Let's verify it's there. Here we go. Nice. So the next step is to create the certificate signing request. The command for it would be looking something like this. And as always, let's try to break it down and to understand it. So here we say OpenSSL. Use your rec utility again and generate new certificate signing request using this key to sign it, and the output of this command will be this file, which is CSR. And as in the previous command, use our configuration file to export some of its extensions. And then when OpenSSL sees this option, it loads this configuration file and looks for the rec section, which is the default entry point for the OpenSSL rec command. We are not using the first two parameters because we pass our own key here, and then the distinguished name is pointing to this section just as before, and prompt works exactly the same way just as when we were generating certificate authority. We also tell OpenSSL to use a v3 rec section when generating CSR, and what this section does is it defines the X509 extensions for the request. It says that the CSR is not a CA, and it specifies allowed usages for the key, like signing, encryption, etc. Alright, so let's generate the request. Let's verify it's there. Here we go. Brilliant. So now let's send it to this certificate authority to sign it and generate our final certificate. Alright, so this is the command that we need. What we are saying here is OpenSSL, use your X509 tool that is normally used to work with the certificates, and we are passing here a CSR, not a certificate, which is here as our input, and we say use this certificate authority to sign it using this private key, and also create a serial number file if it doesn't already exist to track issued certificates, and as a result of this operation create this my-aws public certificate that should be valid for 365 days or 1 year. Press enter. Okay, so the certificate has been created with all our DN values here. Let's verify as always. Brilliant. So just to recap, we have built and configured all of these resources, which resulted in the signed certificate that we are going to upload to our Envoy proxy server that will be terminating TLS encryption. So now it's time to build our Docker images and upload them to ECR repos. See you in the next video.